Hello pre-calc, welcome back. Our objective today is to determine some more properties of polar graphs. And this is actually our last formal lesson of the semester, so you made it. So this should be a shorter one. We're just going to kind of put some pieces together, and then you've got a MyMathLab assignment on these properties. Force pause on your screen. You know what to do from here. Force another pause on your screen. Can you please try this warm-up? So I would like two polar representations for the rectangular coordinate -5, 5. Okay, let's see what happened there. And I don't want you to use a calculator, so I want you to think about where your angle would be. It will be one on the unit circle, one that you're familiar with, in radians, please. And then go ahead and hit continue when you're ready to see some possible answers. All right, I've got some possible answers here. I only asked you for two. I gave you 4 options here. Again, there are an infinite number of possibilities. The most straightforward one is probably this first one in orange here. So if I found my radius, which you could have left as square root of 50 if you're doing one of our quizzes or tests. And then once you plot that point, you see, okay, I am in quadrant 2, right in between the x and the y axis, right? So that in radians would be 3 pi over 4. So that's kind of your first, your maybe principal one. And then I kept my radius and subtracted a full rotation. Then I switched my radius to be negative and subtracted half a rotation, kept my radius negative and added half a rotation. So any of those will work. All right, I'm going to ask that you pause your screen now and decide which of these do you think is the graph or the equation that would match this graph? So go ahead and pause and give yourself some thinking time. You can look at your reference sheet, or you can think about symmetry and maybe some points to be able to narrow it down to one final answer. So go ahead and pause. Okay, hopefully you paused and we're back. I'm going to force pause on your screen now, and you tell me which equation you think matches this graph. All right, the correct answer was D. The reason, one thing I would check first is symmetry. This is symmetric with respect to the line theta equals pi over 2, or the y-axis, so I can cross out these guys, right? Looks great. Let's do this, okay? All right, and so now we're left with 2 options. So why don't we test a couple points, like if I plug in. So let's test let's just a fairly straightforward theta value. I'm going to use pi over 2 because sine of pi over 2 is what? It's a good old 1. So if I plug in pi over 2 here, I get 3 times sine of pi over 2, and again, sine of pi over 2 is 1, so I get 3 here. So if I'm looking at the graph of equation A, I should have the point 3 comma pi over 2, which would be, I think these are going by 2, 4. This would be right about there, which this graph does not have, so that eliminates option A for us. So option D is the winner. All right, so let's continue analyzing that equation. Go ahead and write the equation as well as these questions that I have on the left, and this should match your MyMathLab work pretty much problem for problem. All right, we're back. So these are the types of questions you'll see on your assignment. So is the domain of the graph all real numbers? In other words, can I evaluate this at any angle that I want? Yes, absolutely. So we're just going to put yes here. What is the range of the graph? Well, this comes back to our last video lesson where we found the max value of the absolute value of R. Okay, so remember, when we do that, we take a look at our trig portion, and what we do is we just replace that with 2 things. Do you remember what those two numbers were? 1 and -1. Okay, so to do this, if I replace that with 1, I get 3 minus 3 times 1, which is 0. And if I replace sine of theta with -1, I get 3 plus 3, which is 6, and this gives me, at least how MyMathLab wants, the range of your graph. So make sure you do bracket 0, 6, close bracket. Okay, is the graph continuous? In other words, can I draw this without picking up my pen or pencil? Yes, it is. Is it bounded? Yeah, it is bounded. If I were to draw kind of this boundary here, if I were to draw the circle r equals 6, it's bounded inside that circle, right? So is the graph bounded? Yes. All right, what about symmetries of the graph? Do we have any symmetries? We do. We have a symmetry with respect to the line theta equals pi over 2, also known as the y-axis, right? So I'm going to put theta equals pi over 2, and that's the only symmetry in this case. Force another pause on your screen. Please copy this equation. These questions are pretty similar. The only one I'm adding here is how many petals does the rose curve have. So if you want to just do this one in a different color so you don't have to rewrite all of this, all the questions, feel free to. All right, so is the domain of the graph all real numbers? Again, yes, I can plug in any number here, any radian, and I will be just fine. So we'll put yes here. What's the range of the graph? Okay, well again, now be careful. We're just looking at that trig part. That 5 plays no bearing into it. Okay, I'm just looking at what's the max and min that sign can be, and then that will help me determine the range for this graph. Okay, so it's helpful if you just kind of highlight or box the trig portion. Okay, again, don't let the 5 throw you off. So let's see, if I plug in 1 for the trig portion, I get 2. If I plug in -1 for sine of 5 theta, again, I'm just replacing that. This becomes -2, so the range is -2 to 2. Make sure you go small to large there. Is the graph continuous? Well, yes, if you look at that reference sheet, you know this is going to be a rose curve. Is it bounded? Yes, our rose curves are all bounded. Now find the symmetries. Okay, well, why don't we take, actually, let's do the petals first. What do you think? Do you remember how many petals this rose curve is going to have? It is going to have 5 because n, which is 5, is odd, and when n is odd, that's how many petals you have. Now, if n is even, like if n were 6, I would have 12. I'd have double that many petals, okay? Now, if we're thinking about symmetries, I'm going to show you the graph here in just a moment, but what's your hunch? What would you say that this is symmetric with respect to? I would say theta equals pi over 2 because you're dealing with sine, right? And let's double check the graph to make sure. Yes, here we go. We are indeed symmetric with, with respect to, let's see if I can do this. Yes, that line theta equals pi over 2, and that's, again, our only symmetry. All right, let's just do a couple more to wrap up here. Will you please copy my screen? Okay, so let's take a look at these kind of special circumstances where you have theta equals a number or just r equals a number. So theta equals pi over 3 is going to be a line, right? If I look at pi over 3 or 60 degrees, something like this, and then again it can go into quadrant 3 because r can be negative, right? R can be whatever, but theta has to be pi over 3, okay? So for the domain, all it's going to ask is it all real numbers or not all real numbers? So in this case, can theta be anything you want? No, it cannot, right? It can only be pi over 3. So in this case, we're going to say not. We're going to click the option that says not all real numbers, okay? Now what about the range? Can your r value be anything? Yes, it can. So I'm going to put all real numbers there. Now for the symmetry, take a look at the graph. What kind of symmetry would you say this has? Yeah, this is only symmetric with respect to the pole. So if we were to take, if we were to take this and turn it 180 degrees, flip it upside down, notice I do still have that same line, right, in quadrants 1 and 3. Okay, good deal. Now, I'm going to force another pause on your screen. Let's do the same thing, but for r equals 6. All right, so for r equals 6, this is just a circle centered at the origin with radius 6. Would you say the domain is all real numbers or not all real numbers? And remember, domain is your angle, your theta. Can I use any angle? Yes, we can. All right, now your range, if it were me, I would put the range like that, okay? My MATLAB is not going to take that. My MATLAB wants an interval from 6 to 6, which I don't agree with, but they're not going to take it any other way, so just know that that's how they want you to put the range. Okay, what do you think about symmetries? It's going to have all three, right? It's going to be symmetric with respect to the polar axis, in other words, the x-axis. It's going to be symmetric with respect to the line theta equals pi over 2, also known as the y-axis. And it's also symmetric with respect to the pole, or the origin. All right, you all, that is what we have for today, and I hope that you all finish out the semester strong, and hope to see you next semester.